Yes, you're right. There was a constant on the indefinite integral, but for the definite integral, there is none because we are subtracting, right? If you subtract the constant c, it cancels out, so we don't need that. Okie dokie? So, for this definite integral, you could describe this in terms of x, or you could have described in terms of t, no problem. It doesn't have any meaning. What do we call that again? The variable that doesn't have any meaning but only assists me to integrate and evaluate. What do we call that? Yes, it's called a dummy variable. Very good. And we want to also mention about some properties of the, definite integral. So I'm going to go with. If I'm evaluating the integral from a to a of a function by the definite integral, that's a capital letter of f of a minus capital letter f of a, right? Which becomes a 0. Okay, so evaluating from same bound is a 0. And also if you evaluate, for example, from 5 to 1 of a function, here's the thing. You could do this. It's okay to evaluate like that, meaning capital letter f of 1 minus capital letter f of 5. The capital letter implies the antiderivative, right? That's fine. But we just traditionally, we don't like working with the bigger value on lower bound. We do not like it, okay? So what we want to do then is to factorize by a negative, okay? If you factorize by a negative, there will be f of 5 minus f of 1. Understood? Which is then going to be same as f from 1 to 5 of the function. So, every time you have a bigger lower bound, please interchange the bounds and put the negative sign in the front. Okie dokie? Good. And also, you can, by the sense of working with the integral with the area, a, c, b. Suppose you have the function like that, and we're going to learn that the integration is largely to associate with the area. So if you want to find the area from a to b, what you could have done also here is to work with the area from a to c and c to b. And that is what this property of integration really suggests. I'm going to go to 51. That this is what the property really suggests. We can integrate either from a to b directly or a to c and c to b respectively. And this is actually quite important because, I will give you an example. If I had to integrate from negative 1 to 1, 1 over x, right? What I would have said was, oh, hold on a sec, it's a rational function, right? So if you integrate the rational function, what do you get? Yes, I get a logarithmic function, right? So I will get ln x, absolute value of x, evaluating from where? From negative 1 to 1, right? But look, if I put 1 and negative 1, it's going to be ln of 1 minus ln of absolute value of negative 1. Yes? But then I put an absolute value, that's okay to, work with the positive, right? So negative is fine. So ln 1 is the same as who? Did you say 1? 0. Ln 1 is a 0, okay? Because each power of 0 is 1. So it's going to be 0 minus 0 and 0. This, thank you, Hansol, is actually wrong. This is a contradiction. Why is this a contradiction? Can you tell me? Can anyone tell me why my approach is wrong? Yes. Tell me why my approach is wrong. Because on the rational function, we have something called who? Vertical asymptote. You see? And the rational function looks like that, right? So we in fact had to separate the function, try to evaluate from negative 1 to 0 of the function. And what is it from? 0 to 1. And see if this function really exists. Sorry, if this integral really exists. In fact, they don't. They do not exist. Hence, we had to separate and see how we can do. So we got to be careful with such case with the vertical asymptote. Understood? All right, so far so good. So I'm going to go to the keynote. So we talked about briefly with the property of a definite integral, yes? So you can separate them, no problem. One last thing, the property of even and odd function. Juno, what does it mean by even function? Hansol, what does it mean by even function? Jaegun or Hansol, what does it mean by even function? Or Juno can tell me. Yes. To be more precise, it's a symmetric by which axis? Y-axis. So as you can see, this is the typical example of even, and the symmetric by the origin is the odd function, right? And if you look at the integral here, left and right, what is it? They are the same, isn't it? So for even function, when we integrate from negative a to a, which is a symmetry, we just do the half, right? We just integrate from 0 to a and just multiply by who? Yes. But for the odd function, by the symmetry, it looks the same area, right? However, one is positive, one is negative. Hence, what's going to happen? It's going to be 0. Okie dokie? Okay. So, if I give you an example, let's say I'm integrating from negative pi over 4 to pi over 4 of a sine x. Without a sweat, you know what's this going to become. What is it? Is the sine even function or odd function? Yes, it's odd function. Hence becomes a 0 using the symmetry, the property of the symmetry that we just talked about. Okie dokie? Good. So, whenever we have a example like this, we integrate and evaluate accordingly. Okie dokie? So, if I go to the example of 54, check this out. For part D, by using the fundamental theorem of calculus, this would come out to be who? Who's going to come out as a coefficient? One over 3, yes. And then the integral of a sine is who? Negative cosine 3x. Yes, sir? Good job. And we evaluate that from who? Pi over 6 to pi over 2. Yes? Thank you. Therefore, this is going to be same as who? Negative 1 over 3 times. And who do we put first? Do we put pi over 2 first or pi over 6 first? Yes, I'm going to put pi over 2 first, isn't it? So it's going to be cosine 3 pi over 2 minus cosine pi over 2. And I want you to tell me, man, what does it mean by cosine 3 pi over 2 and cosine pi over 2? What's cosine odd pi over 2? Yes, it becomes a 0. Right? Therefore, they all become 0. Good? You see, so this is how we can evaluate the definite integral.